Hi, good afternoon to you all. So I guess Conceição already told you that due to other commitments, I'm not able to do this presentation live. So I'll have to do it by video. I'm sorry for this. If you have any questions after this presentation, well, Margarida Tomé might be able to answer you, or you might just want to send me an email, and I'll be very happy to discuss with you any issues that are not clear. I'm doing this video recording on a software called Loom that I think it's very nice, but unfortunately I'm only able to shot a video of 5 minutes each time. So I'll have to divide this presentation in 3 or 4 minutes. I'm very sorry for this, and I'm very sorry to Conceição because she will be the one having to manage with that. So speaking about Conceição and UNAC, first of all, thank you very much for the invitation to present this topic about the results on a research topic that has been with us for some years and that we are still developing. Does core characteristics change between harvestings? So why is this important, and how does it relate to the topic of cork sampling? Of course, if we know the drivers that are influencing the cork growth and the resulting cork thickness, and if we know that we cannot control them, for example, climate, it is obvious that we recognize that one cork sampling carried out in today will not present the same results regarding thickness and quality than a cork sample that we will take on the same stands, on the same trees 9 years from now. So what we are aiming to do here is to considering some variables to analyze which are the ones more related with the evolution of cork thickness in consecutive cork extractions. We are considering different groups of variables, tree variables, for example, the tree age, that frequently we don't know, and tree size variables, and usually we use those as proxies for the tree age. The sanitary conditions, management drivers, mainly related to understory management, soil management, and the debarking management. For example, the debarking height, the number of main branches that are debarked in one tree, the fertilization, if it's present or not, the type of fertilization that it's applied, understory management, understory characteristics. Climate variables, from previous literature, we know that climate is one of the main drivers affecting the annual cork growth and the resulting cork thickness. Soil properties, of course, are also very important for the cork growth. So among these groups of variables, we will be concentrating on some of them that we have characterized in our data set, and we will be seeing how they influence the evolution of the cork thickness. So for this, we are using a data set coming from a permanent plot network that is shown in this graphic to the right. It includes 32 permanent plots. 28 of them already have 3 consecutive cork samplings, but on this research we will only be using the data collected from the first 2 cork samples. We are still working on the third cork samples that have been extracted in the trees that are included in this plot. They are circular plots with 30 meters of radius. They are distributed across a large range of climate and soil types and management types. And it is also important to let you know that in this work we will not be presenting the results regarding the soil variables, because we are still collecting those variables. When we consider the two consecutive cork samples that we are using here, they cover a period that goes from 1984 to 2010, and so this was the period that was considered here regarding climate, using annual climate variables. Wait. Okay, so of course it is very important for us to have it very clearly what's the variability of the variables that we are considering, and in this table you are able to see a summary of the statistics of the dendromatic variables and of the stand variables that are included in each one of the measurements that were carried out in the plots. It is important to have in mind, in particular, some variables that later on during the results we'll be focusing on. For example, the number, the variables, the maximum value of the variables that are expressing the debarking intensity. NBRU, for example, reflects the number of main branches that are debarked in the tree, and in our data set we have a maximum value for that of 6. The maximum vertical debarking height, that's 8.2 meters, and the maximum of the total debarking height, so that's the sum of the debarking height along the stem and along all of the main branches. So it's the sum of all of those partial variables. That has a maximum of 28.8 meters. Regarding the debarking coefficient, it ranges, like you can see here, from 0.9, so very low, to 4.7, so that's the maximum value that we have included in our data set. So we think that regarding the debarking management, debarking intensity, we cover a large range of values. For diameter of the tree, we also have maximum values that reflect the production of trees that are very large. And for example, regarding the stand variables, we see that we are ranging from 8 trees per hectare, so very, very low density, to 203, so a little bit more dense stands. So the conclusions that we will take out from this research are conclusions that focus on these data sets, on these characteristics, and that should not be extrapolated to other stand or tree conditions. We use the linear model approach to model the cork growth index evolution. And what is the cork growth index? Some of you might know, but I'll just explain it to the others. It is the sum of the 8 growth years, complete growth years. So after the debarking that is made during summer or spring, the tree will grow what we call the first half cork growth ring. We are not considering that half ring. Then it starts to produce one cork ring per year, of course, and because the minimum interval between two consecutive cork extractions on the same tree is 9 in Portugal, it will grow at least 8 complete growth rings. At the 9th year, then the tree will be debarked again during the spring or the summer, so there we will have another half cork growth ring that we will not also consider. This enables us to include in this research cork samples with 9 years of growth or more. 10, 11, 12, more and more we are seeing some landowners extending the cork debarking rotation periods to more than 9 years. But using the cork growth index, we are able to use all of our cork samples. The first thing that we observed is the significant relationship between the cork growth index taken at the individual tree level from the first cork sample to the second cork sample. So this is a first observation. So now, even if we observe that there is a significant individual tree effect, what we now want to look at is how other variables are, to some extent, explaining the fact that the core growth index increased or decreased along this cloud of points. So the first variables that we looked at were the climate variables. I'll be focusing here on the precipitation, and we saw that the precipitation from the year of growth was definitely affecting the evolution of the cork thickness. For our range of values of precipitation that you can see here in this table, we saw that there was a positive effect, meaning that if there was an increase in the precipitation from one cork growth period to the other, then this would mean an increase in the cork growth index. On the contrary, for the stands where the precipitation of the cork debarking period was decreasing from the first to the second cork sample, the tendency was of a reduction for the cork growth index. We compared our results with the ones from other authors, and they were in fact in agreement with Carita from Spain, but they were not in agreement, for example, with Sanchez and Gonzalez. But when we looked at the range of values from this author, we see that the range of values that characterize their data set are very, very higher. So with a maximum of 1,391 millimeters of precipitation per rain. So maybe this is, we suspect that this might be one of the reasons, the fact that precipitation values here are not for one side so much variable, and from another point of view, they are much higher than the ones that we have in our data set. This is a possible explanation for the results. Regarding the stand variables, number of trees per hectares and basal area, we did not found any relationship with the evolution of the cork growth index in accordance to Sanchez and Gonzalez. But here, on the contrary, Pizurro found a negative effect. Again, looking at the range of values, so this is very important to observe our results compared with the results of other colleagues of other publications that have a range of values distinct from the ones that we have. And here we see that Pizurro has stands characterized by larger tree densities. So this is very relevant for the observation of the results. Regarding the debarking intensity, here what we saw was that our results pointed out either to an insignificant effect, or in fact sometimes we found a positive effect on the coefficient that was fitted in the model, and this was very strange, and this was even not in accordance to a biological interpretation of the results, because of course that sorry for this, of course that does not make any sense from a biological point of view, that if we increase the debarking intensity, this will result in an increase of the cork growth index. So we did not limit ourselves to look at the variable range that we had. What we did was to go and have a look at our data set. And this is what we found. We found that there was an increase of the debarking intensity with the increase of the tree size and of the tree cork calipers. So meaning that when a person is approaching the tree to carry out the debarking, what they are seeing is if the tree is large or if the cork thickness is very thick, then that tree is good enough for you to take more cork. So this means that our data set, because we do not control, because these are permanent plots, these are not trials, we do not control the debarking coefficients, the data set does not fit our purpose here. We do have two trials where we are controlling the debarking intensity, the debarking coefficient, and where we are looking at that effect on the evolution of the core growth index. But that is another publication, that's another work that I'm not presenting today, but I'll be very happy to show you and to discuss with you if you are interested in such. So now, after this brief presentation of our results, some ideas on where we are moving, in what direction are we moving. Now, what we are seeing using, again, this permanent plot data set and the third cork sample is in the fact if this climate effect that we have seen, if it's the same for all of the trees. We'll be publishing the first results on this question recently, but I might already let you know that what we found was that that the trees that are characterized by cork values in the upper quantiles, they are more resilient to climate variabilities, and that the trees that are characterized by cork values in the lower quantiles, so the thinner ones, they are indeed more variable to heat waves. And this is particularly relevant since we know that we are expecting the heat waves and extreme climate events to be more frequent under climate change scenarios. So that's what we are doing now. And the other research topic that we are focusing, it's not only now that we have addressed cork thickness, we are also focusing on the evolution on the core quality. That's some ongoing research. And like I told you at the beginning of the presentation, the collection of soil data in these permanent plots in order to add and to research the effect of these variables that, of course, are relevant because of the tight connection that they have with climate. I'd like to thank you again. These are the list of papers that I was speaking to you about, and the fact sheets that were produced under these research topics. You have them here. Thank you very much. I know that I have exceeded a little bit just of my 15 minutes. I hope you found the presentation useful, and I hope that you have a nice rest of the day, and that tomorrow you also have a fruitful day with this Science to Practice event. Thank you very much, and see you soon. Bye-bye.